Okay, hello everybody. Welcome to the session Mass Spectrum Ion Definitions and Ranging. My name is Martina Heller and I'm a PhD student from Peter Pfeffer, and we worked together on this atom probe toolbox, and I'm really happy that so many people are joined us today to watch how you can range and what you can do with your APT dataset. First of all, I will give you a really short presentation with a PowerPoint, what we are going to do in the next 1.5 hours, just to get a quick overview what fundamental steps we are going to do. So,
sorry, I have to interrupt you, Martina. Geh noch mal kurz aus dem Bildschirmteilen raus und dann nochmal Bildschirm teilen und dann für den Videoclip-Modus optimieren und jetzt nochmal den Bildschirm teilen. Ja, wieder teilen.
Okay, now it's hopefully better. Okay, so first of all, you've already seen that we've created. Okay, I need 1 more minute. I'm sorry about that. Okay, so now, let's start. So you start with a POS or an EPOS file. So in general, you don't need an EPOS file. It's just depending what you want to do with your data. You can also load in a POS file. Then we create our mass spectra. Then we add to our mass spectra ions. Then we range the ions, and then we create, or you can create, a raw POS data table variable or a decomposed POS data table variable. I will explain you what the difference is. So in general, when you load in a just normal POS file, you have the ion index number, X, Y, Z, and mass to charge. And the difference between POS and EPOS is that you have here more information. To create an EPOS file, you just have to go to IVAS, right-click on your reconstruction and create EPOS. So the EPOS file contains a lot more information than the POS file. It's depending what you want to do with your dataset, if you need it or if you don't need it, but I think Peter explained what you have here, more for information. Okay, so then we continue with our mass spectra. We add ions that we add to our figure, some like stem plots here. You can see here in the legend what ion is what. You have also sometimes overlapping peaks here, for example, or also somewhere else. It's like a normal mass spectra. Then we range our peaks so that we define that these atoms with the mass to charge here in this region, for example, are manganese oxide or are zinc or our aluminium here, and then we have our figure, really nice. But at the end, you can see it in more detail, that you can set the range exactly where you want to start and where you want to have it end. So then you have just before the normal POS variable here. Then if you have an EPOS file, you have more information then, and then we can create with our code raw POS variable. We call it, or I call it POS raw, because normally I use as the normal POS file the decomposed file. So for me, when I work with our toolbox that I know, I call it POS raw. In the POS raw table, you can see here that we have 2 new columns, ion charge state. So we add to each ion the charge state and the ion. So before you just had, okay, here at this X, Y, and Z, with this mass to charge, there's an ion, but you did not know what kind of ion it is. And after you range your mass spectra, you know exactly, okay, this ion with this mass to charge is a nickel ion, for example. That's what the raw POS raw file contains, and it's also 1 times positively charged. You also can see here, for example, 2 times positively charged ion. Now we have the option that you can also decompose your POS file. That means that you add again more columns to this table. So in a decomposed POS variable, you have here again the POS file, then the ePOS addition, and here you have like the raw, the ion and the charge state, and then we divide into atom, isotope, and ion complexity. So for example, when you have molybdenum 2, it's divided into molybdenum here in 2 lines. You can see also here the ion index number at the beginning is 2 times 9. Also the x, y, z coordinates are the same in the mass to charge. In general, everything here in front is the same of these 2 lines. But here at the end, you have the atom and the isotope, and you have an ion complexity. The ion complexity defines that you have here an ion that has 2 ions, so a molecule with 2 ions. You can see it down here more in detail. I picked there all of the H2O ions. So you can see here the ion index number is 3 times the same, also the other information. And down here you can see it's divided into hydrogen, here hydrogen and oxygen, and you have here the isotope, and you have here the ion complexity, that's in this case 3. This gives us more options and more possibilities to deal with our data, that we can split up our molecules into single ions. You see this also in your workspace. So when you load in your initial POS file, I call it all the time posin. So my initial POS file is posin. It's just raw data. In this case, it was an ePOS file. So you can see we have this number of ions, and we have 13 columns. So our ePOS file ends here with column 13. Then you can make a POS raw. It has the same amount of ions, but contains just the 2 columns more. And when you decompose your POS file, then you not have just more columns at the end, 3 more, but you also have a higher amount of ions, because now the ions are here, for example, are doubled. Yeah, so in general now we are going to start to range our file and to start with the ranging. So first of all, what Peter not mentioned was, when you want to see the functions of our MATLAB toolbox, you can click here on add-ons and then manage add-ons, and then you can see here our Atom Probe toolbox, and here on the right side you have options, and then you can enable or disable the toolbox. So if you also are going to work on our code, like scripting the code also with us, if you want via GitHub, then maybe it's not good to have the toolbox installed and at the same time also working on the code. And also you can click here on open folder, and then you have the folder open where all of our functions are stored in, so there you can also look. But in general, I think you don't need it. The most important part is that that you have installed your toolbox. Okay, then go back to my working folder. Okay, so I start now from complete the basics again, because I did not load anything in here before. Okay, Peter already mentioned our getting started guide, and I would like to point out really our workflows. So these workflows really helps you through individual steps. If you think something could be made better in the workflows, we are really open to have feedback about them. And you find also some functions here. We try to include every function in our workflows, so that you can see of every function how you can use it. But sometimes really there are functions are not in it, so you can go and check here the functions if you really need to have something really specific. Okay, so for the beginning, I start with loading the ground truth. So I load the isotope table, and I'll load the color scheme. Okay, then I hope every one of you has already done that. I prefer to name my initial pos file posin. You can also name it pos like Peter did it, but afterwards you decompose the pos file so you don't have the initial pos file stored. So it's up to you how you want to do it, and is yeah, really what you want to do. If you are here, that's maybe also some problem. I don't see anything because I have here an epos file, so just hit here, epos, and then I've opened. Yeah. Oh, I need to select it. Okay, then you need to wait a little bit because it takes some time to load it in sometimes. It's depending on the size of your data set. Okay. Sometimes it takes really long. Okay, maybe I continue with telling you something about our workflows. So in general, oh, okay, it's already finished. Okay, but then we will continue with the workflows. So I like to work with the workflows in combination with the command window. So if you, because now you don't see the workflows, just if you have opened the getting started guide, but you can all the time type in open workflow and then hit the autocomplete button, and then you see all of our workflows. So you can also click with the arrow keys through it and select the one that you want to have, and we will start with the first steps workflow. The first steps workflow is like the basic workflow. So what I'm going to show you, it's like, in my opinion, the most important step because it's the first step you do. And when you're finished with ranging your mass spectrum and when you have your decomposed pos file, you can do all of the other investigations or analysis with our toolbox. But if you don't do or if you don't have a decomposed mass spectrum, you can't do anything else with it. Okay, so now we see here our workflow first steps. And Peter already mentioned you have put in a lot of text, and you can also click in the small boxes and just go with the just run this step, for example. You can see here all of these functions are already typed in. It's like, yeah, the same steps. And then you see here creating a mass spectrum. Creating a mass spectrum in this case I really like because you have here a slider, so you can change here your bin size. So normally you need to use this function, spec is equal to mass spec plot. You give in here your initial pos file, you give in here your bin width and the mode. And these two variables you can change here. So you have the mode normalized, or you have also the mode count. It's up to you how you want to do it. Up here you can see the bin width, and you already see if you change something and you need to hit run. There's a small bug, and then your output will be created here. So now if you go really deep and then you hit run, and you see here your output is generated. And that's, for example, maybe too low for us, or it's up to you how you want to have it. And then you go maybe higher to 0.05. For example, you hit run and you have it here, or you go to 0.1 or a 0, yeah, it's here 0.01. That's what Peter mentioned before. It's up to you how you want to have your mass spectrum look like. Okay, in general, when you have here your figure, it's a really nice figure. You can hit here, open in figure window. Then it will create an own figure, because now you've just created your figure inside this live scripts. If you want to later on store more data in this figure, you can't do it inside this live script. So you have to click here, for example, to open in a figure. Then you have it here. Then you have to click oops, not with the plus button, with the mouse on your mass spectra, and you need to type in spec is equal to GCO, sorry, that means get current object, and now you have your file ready. You can also just copy this line, because you can see here all of the variables here are created also in your workspace, and then give this line here and it's open. It's up to you how you want to do it, but here you don't need to write mass spec this line, for example. It's up to you how to do it. Okay, so then I think we can continue and add some ions. In general, you can add an ion with our function ion add. You can see here this function here has a lot of inputs. So we also tried to write a little bit behind our input arguments in a short sentence. What is this, or what does charge state mean in general? Okay, but charge state should be fine. If you don't know something about a function, you could also type in all the time help and then ion add. And then you can see here documentation that first describes up here it's like in general in MATLAB you have then a little bit help. It describes the function, how you can write it with the input and output arguments. The input arguments are described in more detail, and also the output arguments are described in more detail, and sometimes you see we have some more stuff to do on the functions. Yeah, okay, so but we want to add some ions. So for this we use the function ion add. For this we need our spectrum that we already defined. Then we need the ion. In this case it's an aluminium alloy, so I type in, I will change this to aluminium. Then charge state, we can let it be 2. Sum margin specifies a margin within 2 peaks will be summed up. Then we have the minimal abundance. It's the minimal abundance. Then we can choose here between most abundant for the maximum height or selection. There you can select a peak, but in general I use most abundant. Then the maximum separation is the maximum of the mass spectrum within this range will be used for scaling. So in general I will leave it like this, and then you can just hit run. And now you see here, okay, maybe it was silly to use aluminium, because in this case in my color scheme aluminium is really a light color, but I can also try it with silica, for example. And now, oh, I hit run. And now you can see here in green silica. Now, when you know what is in your alloy, you can continue. But we have also other ways, because typing in here each alloy is a little bit, yeah. You can, for example, if you have another alloy, you can then add your ions with your ion table before. So if you generate here these ions, you can create an ion table, and then you can store there the ions. And if you already have done that for a data set, you can reload your ion table inside your MATLAB workspace, and then you can add all of the ions to your mass spectrum. That's one possibility, but I will do it, I think, at the end. And we have another one, that's with the ion list. So Peter mentioned before that we have here the possibility to create an ion list. In this case, you can type in here on top all of the molecule or all of the ions that you have in your data set. So we will start, for example, with with aluminium. Then magnesium. Oops. Then hydrogen. Then silicium. And then copper and zinc. Okay. Okay. So a short question: are you all with me right now? So have you, all of you, the mass spectrum and also the aluminium and silica added to your mass spectrum? Maybe somebody could say a short sentence because I don't know how to open the chat. Ah, I found it. Sorry. No, we did not create the ion list yet. And the other ion list you can't add. That is, it's something I will just show you. You don't need to do it because you don't have the ion table from the another aluminium alloy. Okay. Okay, so then we can create it right now. So I hope everybody has the workflow here and has typed in all of the elements. I can also post this into the chat. So you can just copy and paste it into your workflow. You can also, for example, store this workflow in your own space and name it after your alloy, so you don't have to type in all the time the same in, or you just save the ion list. It's also possible. Okay, so you hit off run to run, and then this ion list is created. Also, it's the same. It's with the elements, the complexity, and the charge states. Okay, it's still creating. A small window pops up. I am looking for it here. So you need to wait until it's finished. Because when you have now your ion list, it looks like this. Again, you see here the possibilities you have and the ion isotopic name, and you see here the master charge. And with this list, we can use an app designed by Peter called Ion Find. For this app, we need the spectrum, we already created it. We need the ion list, we also created the ion list. We need the isotope table and the color scheme, and we need a search range. So that's the range in between our peak. I will explain it when you see it, that's maybe better. So I put for here now 0.05, for example. Okay, I hit enter, and now I have here a small cross. And now you can select the peak like this. And then you see here that you also already see some ions, and a small window pops up. Sometimes if you have two screens, you need to look for it a little bit because it's on my left in this case. And it has some possibilities what can be. So in this case, it's obvious it's magnesium, 2 times charged, but it also could be something of these in theory. In practical, you really need to think about it if that's physically realistic, that could be O2 with the isotope 18 3 times charged. Now we're pretty confident it's magnesium. You can also go to the others and you see the peaks. So if it's this ion, you would have another peaks also. You can go by mouse, or you also can go up and down with your arrow key. That's also possible. Then you hit OK, and that's fine. You can now switch to other peaks, for example, and I like to not hit here run. I more prefer to type in here and hit enter, but it's in general up to you. And now you can go and range your, or not range, but add some ions. But you will see here that you have a lot of possibilities. In this case, it's pretty obvious. It's aluminium. And here, it's the important thing that you see here the abundance of the peak, so where the peak is. And here you have 0.01, up to in this case also, because that's the range in which it looks for. You see here, we have here 0.03. If you just type in here for search range, just 0.01, you won't see 0.02 and 0.03. That's the important part. Okay, so we leave it with aluminium, we hit OK, and then we can continue with all of the ions. In my opinion, that's a good way for peaks that you don't know what it is. So if you know that you have magnesium, hydrogen, oxygen in it, in my opinion, it's here, for example, hydrogen, it's easier to use the ion add function up here. Oops, down here, sorry. Here, no, here, 9, here, 9. Here, sorry. Okay, so if you know the ions, then it's easier just to type in here hydrogen, hydrogen 2 in this case, positive 1 times charged, and then you hit run, and you see it here. I see the question from Mr. Meyer. The problem is with the 2018 version is that you will see the workflows normally. I think I had at home the version 2018b, but the problem is you can't use the run button and you can't use the sliders. So what you can do is you type in your variables and then you can hit here above run section, and it will go through the sections. But unfortunately, these buttons with run and the sliders are, I think, available at version 2019b. So the workflows will work, but you need to type it in. It's not like so handy or so easy to use as the workflow in 2019, for example. Okay, if you added an ion and you don't want to have it, for example, then you can also go to your figure and take the mouse and then hit the ion and delete the ion, for example. If you want to know what the ion is, you can go back again from this one, from the small arrow, and just hit your stem plot, and you can see down here, the one was magnesium or the other one aluminium, and you can add here also a legend. But at the beginning I would refer to not to, because you're just, yeah, adding the ions. So, and now I think everybody of you can add some ions. Yeah, what you also can do is you can just copy this one and type it in here. If you leave all of the variables down here the same, you can leave it like this. And then you can also just change here the ion. For example, in this case, hydrogen. Now we need to write it like this. Oops. And then charge state is maybe then 1. And hit enter, and you see your hydrogen. And I forgot the at the end. Sorry for that. And then you can also, yeah. Okay, so that's in general. Okay, then we need to do it if you want to use it. So, I can do it like this if you want to. Now there's no way to zoom into the mass spec with the Ion Find app, but if you start the Ion Find app, you can hit here the plus button and then zoom in. So I can start it again and show it to you. So I don't have it here. Then I hit here the button. I go there. Okay, it's not working. I thought it's going to work. So you need to first yeah, thank you. Okay. Okay, then I can also post the ion list function here. Elements, then the complexity. Okay, type it. So in general, it's up to you how you want to do it. So you can oops. Okay, so I think I will continue and put more ions to it. I will use ion add. In this case, you see 16, so I think maybe that's a high oxygen peak. And then I will continue with the next one, and maybe 18 is the H2O peak. And here in the middle, maybe, I'm not sure what it could be, and there I will use the ion find app, for example, again. All the time, if you write here a new one, maybe for the complete beginners with MATLAB, you can go with the arrow key ahead and you see the history, what you've already made for comments or for codes, and then you can, with the arrow keys, select one that you redo again, for example. So now you see here the differences, and now you can go through the possibilities and what it could be or not, and you need also to see all of the, or you should see also the other peaks. So yeah, I think in this case it's maybe OH. Yeah, then hit OK, and you have here your ion. Then we can continue. I think here at at 24, for example, that could be magnesium. So I go with, I give you again the ion find function. Okay, and yeah, in this case I will redo ion add. What you can also do is you can write your own script and copy paste all the time ion add for your alloy, for example. So magnesium, you can see it really nicely, and maybe 22, I don't know what it is again. Then I go for ion find. Oops, it's a little to the left. And I will go could be silicium oxide. So I go with silicium oxide, hit OK, and then you can continue. So for example, yeah. Okay, now we go on. This peak, maybe we could, that could be vanadium. Okay, so I add vanadium and I don't see the peak. And the problem is because here should be vanadium 2+. So I can go and look for the peak, and you see it here. So in fact, I don't want to have it here because you also see the peak is not here. So just click on the peak. Okay, and then delete it, and that's it. Yeah. Yeah, still recording. Yeah. Okay, so let us continue. So we go for vanadium 2. Then, yeah. Oh, sorry, the first one, not with the 1, because then you have to delete it again. Okay, what was my last one with the magnesium one is still missing. Okay, so the next one could be chrome. Okay, then maybe also the small one beside the aluminium called the magnesium peak. Now I don't find my peak again. Okay. Yeah. But I want to have this small peak here. This one here. So in this case, use again ein find. Okay. Oh, it's mangan, nicht magnesium. Sorry. My mistake. So manganese 2 times charged, and then the next one. So this one is a little bit difficult maybe, because you see here it would fit the silicium peak really well in this case, but you can also see that you have here like not an exact nice peak. So oops, the peak is not like really nicely sharp. So we think that in this case you have like more events that coming off your sample, and that's an aluminium alloy. So it could be also that this is aluminium hydride, for example, and the peaks will fit really well. So in this case we add aluminium hydride to it, and you can see it fits the peaks well. And now when you have this view and you don't want to have it like this, I prefer to not do it with up here with the hand or something else with the slider like Peter showed you. My preferred way is to just type in axis, and then you go for the x coordinates. So you start, for example, with in this case maybe 20 up to 50, and then you type the y-axis from we just need, for example, 10 minus 5 up to 10 2. Oops. And now you have back your mass spectrum really nice. I will also copy and paste it. I add. Oh, sorry. No. And this one. So you can also do it like you want. Okay, the other one, maybe it could be it's aluminium hydrogen 2. And the third, the really small one, could be 3. But that's really, we don't know it. In this case, we have to do more investigation, but it's in general, ranging a mass spectra, it's not that easy. And it's really depending on also what you want to see. In this case, it's an aluminium alloy with magnesium and silicium, and we want to see how they're dispersed inside the alloy. So maybe it's not like the most important part to range these peaks correctly. Okay, but then let us continue, and here you can see the 3 peaks that will, and the 5 peaks that will match really good with zinc. So we go for zinc, in this case 2 times charged, and okay, and then we have also here really small some copper peaks, so we can also add copper 2 times charged, and we go on to the rest of our peak, or what we still have here. The big ones here is again copper and zinc. I think the small ones we will maybe also for time reasons ignore right now. And no. Okay. Okay. On the home button, but then okay, or also I see Andy London gave another alternatively what you can type in. Thank you very much. I'm also still learning MATLAB, so okay. Right now I would say we are about to finished with adding ions to our mass spectra. Now you can add here the legend if you want. And my question is to you now, how far did you go? I hope you are all still with me. And we can also maybe give you a few more minutes that you can finish adding the ions. And in general, maybe because I think there are a lot of people who are also better than I am in MATLAB, I have a general question. Because when I started to use our MATLAB toolbox and I typed in our function, for example, ion add, and I know there's a lot of input arguments. And if you type in like I did and then you wait after the open bracket, you see this yellow box appear. And in general, it does it at every or most of the time it appears. Sometimes it does not, and sometimes it does appear. But when I now start writing, it's away, and that's a real problem, and I don't know what can I do that it will stay, so I can continue writing and knowing what variable I'm typing in. Because especially for ion add, it would be really helpful if you see here, okay, ion add, at first I need the spectrum, then the ion, then the charge state. So if it goes step by step with you through the entire functions. And we have a lot of functions that needs a lot of inputs. So in our case, it would be really helpful if somebody knows how to fix this yellow bar, so you don't you can easily or more easily work on our toolbox. Okay, maybe all of them who have or who has their mass spectrum with the ions, maybe could give a yes in the participants panel, so that I know how many of you have reached this point. You also don't need to have all ions added that I've now added to my spectra. It's okay if you have just a few of them, because then I know how far you've reached, and then I know if we can continue. Yeah. You can also ask a question. Yes, please. Ah, Mr. Verbeen told or wrote that GetRect requires the image processing toolbox. So okay. Yes, I think also I will go on, and we're going now to range our dataset. So it's also in the workflow first steps. If you go down, we can add a single range to a mass spectrum. So if you want, we can start at the beginning with the hydrogen. You can zoom in your workspace, and then you type in range add, and then your spectrum, and you give it the color scheme. Oh, sorry. Now it's better, or I can also switch more to the right. Okay, range add to color scheme. I give it before. Oh, sorry, to everybody in the meeting. Okay, and then we hit enter, and now we have this cross, and you can give now the line on the left side and the line on the right side, and now you have your range. That's it. You can also see the legend. Now you have here answered in addition your range. You can see it also with the color. Okay, in theory you can go on with again the same command, and then you continue and range this peak, for example. Now a small window pops up, that's why it's white, and you can see here down, you can see a little bit the ion from the H plus and the ion from H2 plus, and now you can see here that both are possible, but that's the amount of 2H plus, and above here it would be the amount of ions of the H2 plus. So it also selects in general the most probable one of the two peaks here, and here it's obviously it's H2 plus. So you hit OK. And then you can, in general, go on further. We've also, that's all. We can continue a little bit also. Does that work with everybody? Oh, in this case, you can see I've added magnesium 2 times because it says me 2 times the same one. So I hit OK. And then I go on the select button and select the ions 1 times and delete it. So now it's just 1 times there. Okay. You can also, does that work also for everybody? I hope so. We have here also a possibility to range an unknown peak, for example. Here, for example, these peaks are unknown. We did not find an ion, also not with ion find. And I see the question from Teska, from Madam Teska. So you can arrange remove. It's the same with the ion plot. You can also go here, for example, again. And then you can select here the range. You delete the range. And then you can range it again. And then, for example, you can also use the other one and range it for the smaller one. But in our case, I think we want to have the first one. Okay. With this range, or with this function, you also have the possibility to add some ranges to peaks that you don't know. So before, for every peak we defined an ion, but now maybe you have a peak, come on, here, for example, where you don't know what ion that is, for example. In this case, you can write spec color scheme, and then you type in a name of it. For example, I name it now unknown 01, and now I can select one, and then an arrow should occur. So like this, because we don't define a color for atom ion unknown 01. In this case, I can also, if you want to really do it, but I would suggest before doing what code I write now, we have designed a function called color scheme iron add. You need as input argument, no, it's output argument, your color scheme. The function is color scheme iron add. You need for it the color scheme, the new iron, and selection you can or not. It's depending if you want to select a color for the new iron or not. So in our case, I would like to, so I type in color scheme, then the new iron is unknown 01, and then I type in selection. Oh yeah, escapes. Oh, okay, no, sorry, my English is not that. Okay. Thank you. Now it works. It added, we can open our color scheme by double click on it. It adds here down unknown. What I missed, maybe it can't use the, no. Delete. Okay, I don't know why it doesn't show the numbers here. Okay, but in general, we can also call it just unknown. We created here in our color scheme another iron called unknown. And now we can go back and use, okay, first of all, I will copy it and give it to you. Verdammt. So, okay, but without the 01, sorry. Okay, and then we range add, and then we give it the same name. And ich mich wieder schreiben. And now we have our peak called unknown. I will give you both of them maybe in the same. Okay, so in this case you can continue. So you can add the ranges to your mass spectrum. And most of the time I would recommend with the color scheme. We have here in general all of the colors from the periodic table, but at the end we added a few ions molecules, but just a few. So what I do normally in my daily life, when I use this toolbox, I add all of the ions, then I open my legend, and then I'm looking for difficult ions, or that I know that are not in my color scheme. So in our case here, you see here aluminium, hydrogen 2 and 3 won't be inside my color scheme. So in this case, before I start ranging, I add them to my color scheme. It's also possible, that's something I will show you at the end, that you can create your own color scheme for your specific data set, for example. So, but first, we will add the aluminium hydrides to our color scheme. So again, we go for color scheme, ion add, but in this case, we use aluminium hydrogen. Then I will type it first in and then I will copy it for you. And in this case, all of the colors will be generated randomly. I don't know why it didn't work, because normally it pops also a window up where if you type in here at the end selection, a window will pop up and you can select this. I don't know what problem it has right now. But I think we can continue. It's more important that we can add them to the color scheme. And we have here the colors. Okay, so in general, if you type in selection back here, or you go for the help functions, and you can read it in the documentation of the function how to do that, you can choose your color that you want. Okay, and now we've added all of the ions to our color scheme that we need. We could go for each range to add it individually, or we use another app called Range Add All. So, but for this, we need the color scheme, really, not the color scheme, sorry, our mass spectrum really nicely, but the entire one. So, not just the middle. Okay, and now we use the app Range Add All. And for Range Add All, we need to use the spec, the color scheme, range margin, and for use min, we just need to type in true. Because this is an app that will go through each round point here inside your figure, so to each peak, so that you can range it. The problem is sometimes that you also have down here these small peaks. So you don't want to go down here and range down here a peak because there is no peak. So we start with this app to draw here a red line, and then we will start ranging all of our ions in a better workflow. So if you want to do it with this red line, you have to write in here use min, and you give here a range margin, because then the mass spectra will not display it like this. It will zoom in to every peak, so you can range each peak really nicely, and the range margin will say how big the range is between, or in the middle is the peak, and how the zoom is, and you will see it. Okay, so we start with Range Add All, we give it a spectrum, then the color scheme, then I prefer 5, it's the step size. You can also take something else, for example 10 or 3 if you want to have closer look, and then we type in true, and I will start with the first click here on the left side and on the right side, and then I hit enter, and you see here a red line, and all of the round peaks here that you marked before above this red line here are going to display it, and the stem plots below this line will be ignored. And now you can start ranging your peak in general, and you see here that's a peak at 64, for example, and I've chosen 5 as my range margin. So I see here it's 5 Daltons to the right and 5 Daltons to the left side. So you can also make 3, then you have a bigger view, or just 10. I prefer 5, yeah. Then you can start ranging. It's not important that you all the time range the one in the middle, and you can continue with ranging your data set. Now again, you have 2 options in this case. I would choose also sync, and I'm going now to interrupt it so I can copy and paste the code line for you. And with Control C, you can end it up, then an error will occur, but it's not a real error. So I hope you have the line now and you can try it out. If an error occurs because you did not include your ion into the color scheme or something like that, a little bit stupid is that the red line will stay. So just go and click here above the arrow and then hit the red line and delete it, and it's away. Also, if there's sometimes a problem with the range and you have then a wide range, you can also just hit the range and then you can delete the range. Okay, and then you can go back, in my case, and start again with drawing the line with range at all again. So basically the red line will be made between the 2 points. That's why you need the 2 points, and afterwards hit OK. So yeah, and then you can continue. Do you have any questions to this app, or please try it out if it works, or if it doesn't work? That would be helpful. If you have now here a peak where you don't see anything or something like that, or this small peak here, you can just hit enter and then you continue with the next peak. Also, if you have a peak and you don't want to range it because you're unsure or something else, just hit enter and then you can continue with the next one. Also, sometimes a peak will be displayed twice if you have 2 possible ions and they are above the red lines, then it will be displayed twice, but just hit the enter button and then you can continue. Does anybody have a question? At the end, when you ranged your mass spectra, the entire mass spectra will be displayed. Oh, yes. And if you have a range where you did not define an ion for, you need to use this unknown part. You can also name it unknown first, unknown second, for example, and then you can add your peaks manually with the range add function, and then you call it unknown first, unknown second, and then you can range or add a range without an ion. But in general, you need the ion first. That's why we started with adding ions to our mass spectra, and then we add our yeah, our ranges. Okay, so now in my opinion comes like the most important step. You save your figure. Because if your MATLAB crashes now, all of your work is gone if you haven't saved your figure now. So I save it in my workspace. Just call it mass spec ranges. For example, you can call it however you want. Because now with the figure saved, you can also reload it into your workspace and you have it and you can continue with working. Okay, so one of the questions from, yeah. Okay, so now we see our legend and the legend is like not really nicely. And we have there a function that cleans up a little bit the legend. All of the functions that I showed before were also here explained in more detail again in the workflow first step, range add, and also range add all. And then we have here the function mass spec show legend. We created this function and you can choose what you want to see. Just the ions, just the range and the ions, or ion and the range. I prefer, you can write here in items the order or what you want to see. The normal or the normal one is that you just see the ions. That's how I do it normally. So you use mass spec, then show legend. And then it's enough if you just type in your spectrum, hit OK, and then you see all of your legend in my opinion, a nice way. You can also, if you want, change the order here or hit here run. It's up to you how you want to do it. On the other side, if you zoom in to your mass spectrum, you see here a little bit, or zoom back again, that now here the range is on top of everything. So you see first the range and in the background you see the text or the ions that we added to our ranges here. So you can also sort your mass spectrum. In the workflow, you can see here, or you can define here an order really nicely with just this drop-down menus, what you want to see first, what you want to see in second order. It's up to you completely what you can do, but we have also here like a default value. That's what I use normally, but in general it's up to you. It's mass spec reorder plot, the function is called, and it's enough to just give it the spectrum. And you see now my preferred order is that you see first text, then you see the ion. You see it a little bit up here because it's the same color with the blue, and then you see the range, and then the background is the mass spectrum. But it's up to you how you want to see it. You have there a lot of possibilities. You could also do it in this order right now, hit run, and then you see the mass spectrum is in front. It's really up to you what you prefer, what you want to do, and it's, yeah, I don't like it like this, so, but it's up to you. Okay, so now with also the right order, we could save it again. It's also up to you. Okay, so what can we do now with this, with this figure, with our mass spectrum? Now we can create a so-called ion table. This ion table contains all of our ions inside our mass spectrum. The function is called ions extract from mass spectrum, and it's enough just to give it the spectrum. And give you the function in the chat. You can copy paste the function and we can open it. You can see here all of the ion names and the charge state. Ion is hydrogen. That's more important if you have like hydrogen 2. It's also split up into the single ions. for example, and then you have the color. An important point to note here is that if you add an ion that is not, and there's no peak inside your mass spectrum, and you don't delete it again, it will be also shown inside your ion table. Also, when I added the magnesium two times to our mass spectrum, it would have come here, into the ion table, would have shown up here also 2 times the magnesium. Here would have been 2 times. So keep in mind that every ion that you add to our mass spectrum and that isn't there, that you also delete it, because otherwise it will be in your ion table. With this ion table, you can also save it as an extra variable. For example, save it as ion table in your work folder, and you can use this ion table later on. And if you have another sample from the same material, that you can add all of the ions to your material, and that's a little bit easier. Okay. Then with the then we can make our range table. I call it range table. Is ranges extract from mass spec, and also you need the spectrum that you give it, and you have here a range table created. You can see here the range name, then the charge state, the master charge begin, the master charge end, the volume, the ion table, or the ion, so in this case 2 times again, and then you see the color. With the range table, now it's possible to decompose your POS file or to make a raw POS file. So we start with the POS raw file. So POS raw is, the function is, I forgot to add this one. Genau. Oh yeah, and we will send you during lunch break the mass spectrum. So when Peter continues with the next session, we can all have a fresh start from the same point again. So don't worry if you did not get till the end right now. You can have a fresh start with the next session. Okay, POS raw, POS allocate range. And then we need to give the POS in variable. In this case, that's why I prefer to write POS initial, because otherwise you would overwrite now your POS file. So POS in, then the range table, and then you have there the option, there you can write raw or decompose. Okay, so POS in, then the range table, and then we want to start with raw. And it takes a few seconds, and then we have here our POS raw file, and you can see here also down here in the workspace that we have 2 more columns, and we have now at the end the ion and the charge state that we have ranged here. And then if you want to decompose your POS file so that you also have not just also the molecules as ions and atoms decomposed, you can take the same composed, and we prefer, or it's how I do it, I name this, or also in our workflows is also based like this, that we call our decomposed POS file POS. Okay, I will copy paste for you both of the lines. And we have a look on our POS file. So in general, when we talk in the workflows, or we write in the workflows from the POS file, we all of the time mean decomposed POS file. And our POS file now has the ion and the charge state like the raw POS file, but also has in addition the atom, the isotope, and the ion complexity, as I explained it in the beginning. And that's the basic what we do now, or with this variable called table, you can continue with further analysis and with our other workflows. Okay, do you have Any questions? Did you got to this point? Maybe you can give me a short green yes in the participants list if you have reached this point. I see 5. And my Hiwi student. Yeah. Yeah. Okay. Do you have questions? Otherwise, you can also write to us or because otherwise I would close. Yeah. Yeah. Yeah, if you have further questions or something like that, you can write to us co-hosts. If you have also a big problem, you can write directly to the host, to Tonia Kloos. She will divide you into a breakout room where we can help you. And otherwise, I would now leave you to lunch and wish you a nice lunch break. And then have a nice afternoon with us. And I hope you enjoy working with our toolbox. And I'm really happy if you also try out our toolbox and then give us feedback so that we can improve it and make it better at the end. Okay, then have a nice lunch.